Reed, just let him do it. Be a little patient. All right? Okay, somebody said 19. Is that right? Oh yeah, this was just kind of drawing it out, right? Yeah, you were allowed to draw it on the. All right, and to me it was just a matter of finding the measure of each side, correct? Do you remember how to find the measure of each side? Yes, 3 minus -1 squared, -1 squared, then square root. So you have to do that for DE, for EF, and for DF. And then you have to do the same thing for GH, HI, and GI. And sometimes to me it's easier just to graph it, but for some people it's not necessary, right? Anybody? What? Let's look at 15. Okay, so on 15, are the triangles similar? Initially it doesn't look like it, right? Because I see an angle and a side. Anybody want to give me some help on 15? Yeah, vertical angles. That's exactly correct. So we know that this angle right here is congruent to this angle right here. So now we know that it's angle-angle similarity. Right? So angle-angle similarity. All right, now is that all it is? All right, now you just have to write the similarity statement, right? Which to me is easier once you label the angles, right? So JKL is similar to PML. You see that, right? Now, sometimes I tell kids, if you ever have trouble, just make this the third. And now it's just easier to see. Anybody else? Anybody else? Anybody else? Nothing? You okay with yours? I didn't do it. What's that? Yeah. All right. Do you need me to show you something, or you think you're good? Okay. All right. So now, while I'm collecting the homework, let's take a look at 7-5. All right. So you go ahead and I'll just take a look at your paper. I don't need, if you did the work, some of the work on notability, that's okay. Just give me your work. There you go.
Yeah, I do have paper.
Thank you. Make sure your name's on, guys. When you head your paper, put your name on it. You don't have to worry about it. Thank you.
Oh no, you said, wait, which one's Jake?
Okay. Now, here we go. So for today's assignment, again, everything is setting up proportions. All right, everything is setting up proportions. So here we go. Let's take a look at number 1. All right. Now, notice that those are parallel lines, correct? For number 1? All right, so now let's go ahead and see what happens. XM is 4. So I'm going to write that in there. Xn is 6. Nz is 9. And we're trying to find xy. So this is missing right there. Do you agree with that? But we're trying to find xy, which is this guy right here. Do I see that? Go ahead. Is it 10? How did you get that?
It's 6 and 9. I did 6 is 2/3 of 9. 7 4 is 2/3 of 6. So 4 plus 6 is 10.
That's exactly correct, actually. All right. Now, again, that was pretty impressive. All right. Now, you, in my opinion, if I was looking for x here, I would have taken a look at 9. And again, not that it's different, but I would have said 6 times 1.5 is 9, right? So 4 times 1.5 would be 6. And then xy would be 10. So that's really good. Now, so what are we saying here? Does everybody notice when you have parallel lines, it cuts the sides of the triangle into proportions? All right. So at first, I always thought that it would have to be this over this whole length is equal to this over the whole length. Come on now, please pay attention. Does that have to be true? And the answer is yes, of course. Right? That has to be true also. But there's a shorter way. The shorter way is just to say when you draw parallel lines that xm over my has to be equal to xn over nz. Does everybody see that? All right. So today's lesson is basically we're just showing you the different ways that when you draw, for example, angle bisectors or medians, it also is dividing the angle in, or the triangles in proportions. All right. Again, I think that's just pretty easy. All right, everybody okay with that? All right, so now let's look at the next one, number 2. Let's see how that works out. So I'm just going to move this out of the way. All right, and now let's look at the new one. Xn is 6. Xm is 2. Xy is 10. And we want to find NZ. All right, so this is the missing piece that they want right there. All right. So what's MY?
8.
8. Does everybody see that? Say it. Do we agree it's 24? Right. We could say that MY is 4 times XN. So we agree with that? Or, please watch. Does everybody see that xn is 3 times xn? Everybody see that? So now 3 times 8 is still what? 24. So everybody see how that works out? Or it doesn't matter, again, what proportion you use, it will always be true. Anybody have any questions? All right. So now let's look at number 3. So now we just have to determine if the lines are parallel. Well, they're probably going to be parallel if the parts are what? Not equal necessarily, but say it. Yeah, proportional, right? Not necessarily equal, but what? Proportional. All right. So let's set this up and see. BC is 15. And BE is 6. Well, as soon as I say B is 6, I just automatically put EC as what? Sometimes 8. Today we'll call it 9. DC is what? 12. And AD is what?
8.
8. So they parallel. Why not? Why?
Because 3 times 2 is 6, and 3 times 3 is 9, 4 times 2 is 8, 4 times 3 is 12.
So let's talk about it as a proportion.
6
All
over
right.
8.
6 over 8. Thank you. 6 over 8 is the same as what? 9 over 12. All right. Both of those reduce down to 3/4. Everybody good with that? Does it have to be that way? No. We could say 9 over 6 and 12 over 8. All right. Anybody have any questions? So that would be what? Yes, they are parallel. Yes, they are parallel. All right, let's take a look at number 4 now. Triangle JKL. JK is 15. JM is 5. So then MK is 10. Good. Follow with me. LK is 13. PK is 9. So LP would be
4.
Yes or no? Definitely not, right? 5 over 4 is not 10 over 9. So, no, they are not parallel. Everybody okay with that? Yeah, I told you guys. It's very easy. I hope you're doing the work. I hope you're doing the homework. All right? I just think setting up proportions is simple. All right? Here we go. What do you think mid-segment means again? Middle, right. It's the middle, exactly. All right. So we would say in this case, if JH is a mid-segment, that means these two things are congruent, and these two things are congruent. So everybody agree with that? And so, somebody tell me what you think X is. Take a shot at it. 11, of course. It's 11. It's in the middle, right? Halfway, right? So it has to be 11. All right. Now, if this right here is a mid-segment, all right, now if I draw this right here, guess what's true about all 4 of those triangles? They are definitely congruent. Very good. They are definitely congruent. All right. Because, again, this we said was equal to 11, which makes this side 11. So I could do 3 marks here. Now you can see the triangles are congruent by side. Right? There's also overlapping angles and stuff like that. So, but again, that should be kind of obvious for us. Right? So this right here would be 1 tick mark. This would be 2 tick marks. All right? Everybody okay with that? All right. So obviously number 6. Wow. Slow down, guys. Take a deep breath. 10. Everybody all right with that? That was a tough one. All right. I know. All right. Let's refer to the map. All right. So it says, if the distance from 3rd Avenue to City Mall along the street, State Street is 3201. Do we have that marked? No. So we have to find that. So from 3rd Avenue, I have to find 3rd Avenue, all the way to what? City Mall. So is this what we're saying from here to here? Is anybody else seeing that? Is that 3201, right?
Yes.
All right. So we should be able to figure this out pretty quickly. All right. Of course, everybody's got their calculator out. All right. So somebody tell me from Union Street to City Mall is how much? 2,039. All right. So now, it says find the distance from 5th Avenue to City Mall along Union Street. Find the distance. Wow. I think what they meant was find State Street. Let's do this one. Am I just not reading that right? 3rd Ave. Refer to the map at the right. 3rd Avenue and 5th Avenue are parallel. If the distance from 3rd Avenue to City Mall along... Oh, I did do the wrong one. Yeah, I did do the wrong one. Everybody see that? Right. Okay, so that was not accurate. So 3201 should have been this guy right here. 3201. So State Street now. Somebody help me with that. 2145. 2145. All right, so now, please, you guys set up the proportion, cross multiply, divide, and tell me how far it is from Union Street to City Mall. Tell me what that is. Somebody? $2,000. Say it again. 0.3 feet. Someone else verify that, please. And if you don't know how to set it up, now's the time to ask. Good. 2,145. Why is that?
Because it's equal to State Street.
Yeah. So that's what I'm saying. Please set up that proportion. I'm trying to show you guys. You have to participate. I'm asking you to solve the problem and verify the information. All right? I prefer that you write the proportion down, and once you write the proportion, it's just cross, multiply, and divide. Do the work. Don't let someone else do the work for you. That's what the problem is. Everybody's good? All right, you verify. I don't know if you're verifying. Right? I'm trying to figure out what some of you are doing wrong. All right? And it's, part of it is not doing what I'm asking you to do right now. You good? How can you be good? Where's your calculator? So how are you good? All right. Let's take a look at 8. Say it again. Okay, so good question. So we just made a fraction. Now look, honestly, here's how I did it. All right, or here's how I would want you to think about it. Look right here. That's what I did. I'm drawing a fraction. Ready? Watch the fraction. That's the fraction. What am I showing you? 1162 over 1056 equals x over 2145. That's all there is to it. That's it. Can you write it a different way? Yes. I don't care how you write it. You're supposed to see fractions. All right? We are looking at the fraction on the left is equal to the fraction on the right. And that's what I'm saying. I just don't think it's that hard. All right? Set it up on the calculator, cross multiply, divide, and double check your work and make sure that's good. You should write the proportion. I don't care about solving the proportion. You should write the proportion. All right, and use your calculator. All right, everybody good now? Anybody? All right, so here we go. Let's look at number 8. All right. So it looks to me like that is called a what? This parallel line, or this line right here, is called a what? It's a mid-segment. The only reason it's a mid-segment is because these two sides are equal. If those two sides are equal, then what's true about the other two sides? They are also equal. All right? We're not solving that. All right? Let's go on to something harder. You can do that on your own. Everybody agree? Well, that's simple. I'm going to go to some of the harder problems. Maybe that's where I can help you the most. All right, I'm not sure. All right, so number 9 looks really complicated. All right? But what do you think is true if this right here is congruent to this right here? The other two sides have to be what? Now, we don't even have to tell you that. You should just be able to say, well, that's probably true. All right? So now these two sides over here equal to these two sides over here. Everybody okay with that? All right. Now, like I said, I'm trying to really focus on some of you guys who are trying to do better, right? But if you're trying to do better and you're not participating in class, me standing up here doing the hard ones is not going to help. All right? So I thought I would go down to the bottom of the page today. All right, let's start at 40 and 41. All right, let's look at this. I don't think it's any harder. All right, everybody look at 40 and 41. Draw the picture. Let's go. Don't be lazy. Draw the picture. And it's going to be the same picture for both of them. Give you a second to draw. Okay. Now we're just labeling, correct? So let's label. I'm going to label it over here. You guys go ahead and label on yours. Okay, here we go. Blow it up. All right, so here we go. X plus 5. BD is 12. AC is 3x plus 1. CF. So now we want to make these parallel. So if I want to make those parallel, then what's true about those sides? They are proportional. They're proportional. Do you agree with me? Not congruent. You can't say x plus 5 equals 12. Because if x, let's just say x is 7, right? Please, that was a good mistake, some of you guys. That's a 7, right? So over here, that would make that 22. Now, are they parallel? No, because they're not proportional. Does everybody agree with that? All right. So now, what I need someone to do is I need someone to tell me what the proportion would be. Tell me, Charlotte.
X plus 5 over 12 equals 3x plus 1 over 15.
Perfect. Someone else tell me another proportion. Come on, Virginia, tell me another proportion, or tell me what proportion you want to write. Over, I know what you meant. You meant 15, right? Okay, tell me a different one. Read.
12 over 15
Yes.
equals x plus 5 over 3x plus 1.
That's what I'm trying to tell you, right? You hear what he said? We can do this proportion over here. 12 over 15 is equal to x plus 5 over 3x plus 1. Do you agree with that? But again, what I try to tell kids, to me, my brain just sees what two fractions. If I just take this right here, right? And, you know, to me, this is how my eyes look at it. That's a fraction right there. x plus 5 over 12 is equal to 3x plus 1 over 15. Do I agree with that? That's not hard. All right, that was 40 and 41. All right, those are usually the hard ones. All right, so I'm comfortable with 41s. Do I agree with that? All right, so let's go down to, I know this we're not doing. All right, let's see if it's possible that 38 could be harder. So everybody look at 38. All right, take a minute, draw that shape real quick. All right, it's kind of annoying. Draw one triangle. Doesn't have to look exactly the same. Draw a triangle, and then you have 4 parallel lines, or 3 parallel lines. Come on, everybody should be drawing it. All right. Label the letters. Put the letters in there. All right, so here we go. Let's see if I can label this. LK is 4. MP is 3. PQ is 6. KJ is 2. RS is 6. LP is 2. Okay, so now we want to find ML, QR, QK, and JH. All right, it's just a bunch of proportions, right? So LM should be pretty easy. Everybody should just be able to look at that and say that's obviously what? Everybody see it's obviously 2, right? 3 is half of 6, right? So let's go ahead and knock this out and say this is 2. So now, what is RQ, obviously? Everybody agree? Obviously 3. Now, okay, I'm up here saying obviously it's 3. Someone said 3. And you might be sitting there going, I have no idea what he's doing. So let's look. So I'm looking at this part right here. This is what I'm looking for. Let me do a good job here. This is what's missing. So I'm looking at this relationship right here with this relationship right here.
Is it
2 is half of 4.
and 3 is half of 6?
That's why that's 3. Right? You could also say 2 over x equals 4 over 6.
You also see that there's a pattern where like the bigger segments are like always on each side, always either 6 or 4. And the smaller
I didn't even see that. That's good. But that you're right. That doesn't always work. You with me? That's a good pattern here. But it's not always true. All right? That's very important. All right? So we can say now quickly HJ is how much? 4. All right. I'm happy with that, guys. All right. Now, all right. This is actually KQ could be considered a little tricky. Somebody tell me how to figure out what KQ is. What proportion am I going to use? Come on, someone be brave. Tell me. 2 over. Okay, that's good. All right. That's not accurate. I see what you're doing. Come on. Now, look, what I try to teach kids on this part right here What does that correspond to? No, what side of the triangle?
Oh,
Yeah, thank you, LP. Does everybody agree with me? Right, does everybody agree with that? So I can write 2 over x is equal to what?
2 over 2.
Come on now. Now, this is the one that's been on the
6
SATs
over
a
9.
lot. Definitely not. Remember, this right here, and the reason I'm saying that is because I don't care. I don't care. There's no reason to laugh. That's the small triangle, and this is the what? Large triangle. That's the small to large. So someone else tell me. 2 over x is equal to... What is the answer? Can anybody tell me what they think the answer is to KQ? You might be able to just sense.
3.
What do you think? 4? What do you think? 3? No. What is it? How can it be the same? It's okay. Doesn't matter. Come on, kiddos. Nothing right so far. I'm asking you, small triangle to large triangle. Tell us.
6.
Of course, obviously, 6. Obviously, 6. Some of you sitting there going, that is not obvious because I don't see it.
I do not see it.
Nope.
I said small triangle to large triangle. All right, so what am I trying to show you? This right here is the what triangle? Small triangle. This right here is the what? Large. So I have small to large. So what is the small side of the triangle? Where is a 6 on a small triangle?
2.
And the large would be what?
6.
Oh my god, 6. Stop.
You see it now? Come on now. Again, I'm giving you a little bit of a hard time, but this is what I'm talking about. I would much rather you say something completely wrong, right? At least you're trying. Some of you just sitting there just going along with my notes. Yeah, man, he's good at that. He's real good, actually. Probably the best you're ever going to see. All right? But that's not helping you if you're not trying. Just like I said, I don't care if you said it was 2. You could have said it was 1. I wouldn't even care. All right? Now, it's the small triangle. All right? So if you want to look at the small triangle, we are looking at this right here is 2. The large side would be what? 6. You have to kind of separate that. You have to kind of separate it. Would it matter if I chose the bottom triangle? No. Now, again, most people said 4 because they were a little lazy. All right? And the reason why I'm saying that is because, listen to me now, please. This will help you with all of the problems. This right here, this is a left side of the triangle. This is a left side of the triangle. This is the top of the triangle. Is this the top of the triangle? No, it is not. It is part of the top of the large triangle. It is not the large triangle. That's where some of you are making your mistakes. Does everybody see that? Yes.
So basically, it's like get the side of the large triangle.
Yes, exactly. Exactly. You have to do the side of the triangle. Or I'm going to have to erase all this again. You have to get the side of the triangle that corresponds, LM corresponds to KM. You see that? Now, this is some of you guys, I understand you're thinking, whatever that was. This right here and this right here are not, is not what I'm talking about. That is proportional to these sides down here because it's cutting the larger triangle. into proportional parts. All right, hopefully that made some sense. What?
We also do the small and large triangle is equal to like 3 over 9.
Yeah. Right? Exactly right. Good? All right. So again, that's a very good problem. All right. Let's take a look at 36. Here we go. Draw 36 real quick. Let's see if it's getting easier. All right, draw 36. All right, now let's label it carefully. All right, so WX is 7. WY is what? Uh-oh. WV is
6.
and VZ. Uh-oh. We have all kinds of problems here now. All right, come on. I want someone to be smart here. I want someone to tell me the proportion. Go ahead. Good for you. Try. Yes, I know you wanted to. And again, here's what I'm trying to tell you. Get over the fear of being wrong. All right? You're going to be wrong so many times. If you stop talking because you're wrong, you're just never going to get smarter. All right, go. Give it a shot. Good. I'll write that down. 6 over a minus 9 is equal to. Now you know there's something wrong with that, right? Because look, here's what you're supposed to be telling me. 6 is from here to here. A minus 9 is from here to here, right? 7 goes with 6. But WY doesn't go with VZ. True? So tell me what XY is. Yeah, okay, so what if I told you this? What if I said that WY was 10? Put your hands down. If WY is 10, what's XY?
3.
So now you're going to use that information in your brain. How did you get 3? 10 minus 7. So now replace the 10 with what letter? So what is XY? Shh. That's how easy it is. All right, so listen, I try to teach kids that all the time. It's easy if they're numbers, but all of a sudden you put a letter there, and like, I have no clue what to do. You do with the basic what you would for the complex. You just have to see that. All right, so now it would be 7 over what? So that's what I'm trying to show you right there, guys. Those are like the SAT type questions. All right, where they're not just going to set up an obvious proportion. All right, you're going to have to do something to figure out what the missing side is first. All right, do I care about solving that? No, because you can't do that. There's no point in doing geometry. Okay, so let me see here because the bell's getting ready to ring. I don't think if for some reason there's a proof, I think I left out the proofs. You don't have to do the proofs, okay? So please take care of this business now. That's what I'm talking about, guys. All right, do the problems. Don't just quit because you can't do it first thing.
Well, these are like 8 and 9 that you said were like 2. You should still do those.
Yeah, I want you to finish it all. Some of you need practice. Good job, guys. I think.